Hello, this is David Liebel, your instructor in Circuits 1, and I'm going to talk for a little bit about section 3.4 in the textbook, current division. Current division describes the relationship between currents in parallel resistive networks. Make this IS, make this I1, and make this I2. So we'll start with a simple example. In this simple example, I want to find I1 knowing only IS, R1, and R2. I want to find a relationship that mathematically relates I1 to the two resistor values and IS if I know IS. So let's look at how this works here. So I'm not even specifying whether there's a current or voltage source here. I'm just specifying that I know IS. I may not know VS, but what I do know is that R1 times R2 over R1 plus R2 is the parallel equivalent resistance. That comes from 1 over R1 plus 1 over R2 for two parallel resistors. And so I know that VS equals IS times R parallel. Also, once I know VS, I can find I1. So I know that VS over R1, that I1 equals VS over R1. Or that VS equals R1, I1. And since this is true, and this is true, and then this is true, that is equal to IS R parallel. And so the voltage across this resistor is the same as the voltage across the parallel equivalent resistor, RP. The voltage is the same, so you have two Ohm's law equations, one for this parallel equivalent. And so if I want to know I1, knowing IS, I just say IS R parallel over R1. Now, if I plug this in, you're going to see that this is IS R2 over R1 plus R2 times R1 over R1. Because this is this R1 and you have this R1. The two R1s cancel and you end up with I1 equals IS R2 over R1 plus R2. Now let's look at that. It's a lot different than the voltage divider equation. The current in this resistor depends on the magnitude of this resistance divided by the sum of the two resistors. You might recall that in the voltage divider equation, we were looking for voltage and not current, but V2 was equal to R2 over R1 plus R2 times Vs. That's called the voltage divider, and it works with series resistors. And the voltage I'm looking for is the voltage across R2, but the current I'm looking for is the current through R1. It's related to the opposite resistor divided by the sum. And that's just because of the math. When you take R parallel here, I1 is equal to IS times R parallel, that's the voltage, divided by R1. And so you end up with an R1 in the numerator and then an R1 in the denominator that cancels and you get R2. So that is the current divider equation for a parallel circuit. And this is a general result. So in general, It doesn't matter how many resistors I have. I'll just draw this at the bottom of the page. I1 is always going to equal IS times R parallel for the whole thing, which is the voltage across this, divided by R1. So sometimes the parallel resistance is 1 over R1, 1 over R2, 1 over R3, but regardless, you end up with a relationship that's ISRP over R1. That's the current division equation. Now you can solve circuits with that. There's an example 3.7 in the book, similar to 3.7. I don't want to give you the same one in text, in the e-text. I'll give you one that's similar but different, so that you can look at both examples. And we're going to use current division and voltage division to solve this circuit. Okay, so what do I know? Can I find this voltage? I want to find, let's say I want to find this current. All right, so what did I say? I said R parallel times IS over, in this case, 25 ohms should be I25. All right, so what is R parallel? Let's find that first. R parallel is 1 over, I'm sorry, this is 40 ohms. Well, didn't make that look any better, but that's 4 ohms rather. So this is 1 over 36 plus 4, because they're in series, plus 1 over 20. These two are in series. Plus 1 over 20, plus 1 over 25. And that's the parallel resistance. So I have 1 over 40. And that gives me 8.69 ohms. 8.69 ohms. And so that tells me that if I redraw that circuit, 8.69 ohms gives me the voltage, Vs. And that is 43.47 volts. Vs equals 5 times 8.69 equals 43. We'll just say 5 volts. But I wasn't looking for that. I'm only looking for that current. So can I go right into this formula? Sure. I25 equals 8.69 times 5 amps over 25 ohms. .73 amps is what I get as an answer. So here in the numerator I have ohms times amps divided by ohms, which gives me amps. I have 1.73 amps. Now if I want to check that, I should be able to take this voltage and divide by 25 and get the same answer. So to check, you should like to be able to check your answers. I found that voltage. I might as well use it to check. That's 43.5 over 25. That's volts over ohms, which gives me amps. .74. Also, I rounded somewhere, but those are basically the same. All right, so you can use the current division formula, which is the parallel equivalent of the entire circuit divided by the resistance times the source current to get the current. Okay, so that's